Well, hello everybody. Hey, what I need to do with you today is I need to cover with you how to find the area between two curves. It builds off of what we did last time when we found the area bounded by the x-axis. What you're going to see today though, guys, is we will graph some functions, and then what we have to do is figure out the intersection of those functions, and we'll be finding an area of something that looks like that. The key parts of today is we have to figure out these x values of points of intersection. That'll give us our boundaries of our antiderivative, and then the rest will be review. You're going to also hear things like today you're going to hear upper bound and lower bound. Upper bound just means this: when you're coloring, when you're shading in the area, the upper bound is the graph that stops you from going any higher. Then that means the lower bound would be the graph that stops you from going any lower. Now, so that this video doesn't last very long, here's what I've done already. If you would, look at your class example sheet. It says sketch the region bounded by the graphs of the two functions given, and then find the area between them. Well, I cheated already, so I didn't have to graph while the video was going. So guys, I graphed the parabola 2 minus x squared. It's right here. And I graphed the line y equal x right there. Here's what we're going to be finding. We're going to find the area of the part enclosed by those two graphs. So really, guys, if you look at it, what we're going to be finding, we're going to be finding the area of this part right here. So your job will be to do this. You'll need to graph it using your graphing calculator. Now do a good job graphing it, because you need to figure out the x-intercepts of the intersection. You can do that using second calculate on your graphing calculator, or if you do a good job graphing it using your window, it'll become really obvious. So guys, I want you to notice right here, when I look at my x values, this x value is -2. This x value of the point of intersection is x equal 1. Now, also notice this. Here's the parabola. Here's the line y equal x. As I shade this in, the upper bound is the graph that keeps me from going higher. Now notice then my upper bound is the parabola. My lower bound is the line y equal x. So here's how to find this area. It's going to be the antiderivative of, now look at your x values. This x value of point of intersection is -2. This happens to be 1. So it's going to be from -2 to 1 of the upper bound. So my upper bound is the parabola. So I'm going to have 2 minus x squared minus, always minus, the lower bound. The lower bound is this line right here, which is x. Now technically, guys, there is a dx behind that. Now here's what I'm going to do. I'm going to simplify this before I do any work on it. So I'm going to think of this as -x squared minus x plus 2 dx Now we're going to find the antiderivative of this. So I'm going to have -1/3 x cubed minus 1/2 x squared plus 2x. And then I'm going to evaluate this from -2 to 1. Now remember, I need you to show me f of 1, and I need you to show me f of -2. So what I do is I try not to use my calculator sum. So I'm going to plug in 1, and I'm going to get -1/3 minus 1/2 plus 2. That's what I get when I run 1 through there. Then it's going to be minus, and notice I put a parenthesis, Now run negative 2 through there. Well, negative 2 cubed is negative 8 times negative 1/3, so I'm going to have 8/3 minus negative 2 squared is 4 times a half, looks like 2. I then plug in your 2 into there. I'm going to get negative 4. Now at this point, I'll probably pick up my calculator and I'm going to run that part right here through my calculator. And when I do that, guys, I got that the area between the two curves right here should be 4.5. You might pause the video and make sure you can run that through and everything, but that's the lesson today. You're going to have some curves, and then you're going to have an area bounded by it, and that's what we're finding. Now, guys, it'll always be the antiderivative of your upper bound minus your lower bound. So, if you go on to your number 2, I did the same thing just to speed this process up. I graphed the parabola x squared plus 2 right there. I graphed the line y equal x. Now notice that they don't intersect. So I need some vertical lines in there to give me some boundaries. So what I'm going to do is find the area between x squared plus 2, y equal x, the vertical line x equals 0, and the vertical line x equal 1. So here's the area that you're finding. Well, in this case, guys, it's a little easier when you set your antiderivative of. When I look at my lower bound and my upper bound, my lower bound was 0, my upper bound was 1. My upper bound is the parabola. So I'm going to have x squared plus 2. There's my upper bound minus my lower bound, which is x. And then technically this is quantity dx. Now, you might say, well, wait, what happened to that 0 and that x equal 1? We used them right here on our boundaries. So now, guys, from here, let's just find this antiderivative. So it looks like I'm going to have 1/3 x cubed plus 2x minus 1/2 x squared. And we're going to evaluate that from 0 to 1. So now let's go ahead and run the numbers through. Let me get some ink again. Looks like that went away. So let's run 1 through there. If I do that, I'm going to have 1/3 times 1 plus 2 times 1 minus 1/2 times 1 minus, if I run 0 through here, I'm going to get 0. Run that through your calculator or your brain, and we should get that little area right there is going to be 11/6. So upper bound minus the lower bound. So I've done 2 easy ones for you. Now we got to do a couple little tougher ones. So guys, if you would, look at your number 3. Notice that I got a cubic that I graphed. Here's my cubic that I graphed right there. And then I graphed the parabola right here. Now, notice this though this time. If you look at the area, you might be thinking, well, which one do we do? The answer to that, both. Notice that there's an area right here. Sorry about that, the PowerPoint froze up, so I might repeat myself. Notice that here's an area right here that we need to find. And there's a second area right here that we need to find. So this one gets a little tougher than the front 2 that we've had. Notice that we're going to have 2 boundaries this time, guys. Notice that the point of intersection was here at -2, -8. Another point of intersection at 0, 0. Another point of intersection at the point 2, 0. So I need to find this area added to this area. So this one's going to work us for a little bit. So here goes. I'm going to have the antiderivative of, let's pick on this one here first. I'm going to go from -2 to 0 of the upper bound. So look at what you got. My upper bound is the cubic part. So I'm going to have that upper bound, which we said is the cubic, which is 3x cubed minus x squared minus 10x. There's the upper bound minus the lower bound. So go through and change all your signs. So the opposite of negative x squared becomes positive x squared minus 2x plus. Now let's go get this one. Well, its boundary is going to be 0 to -2. Let's put that correctly. Yep, it's going to be 0 to 2. Now, peek at this though. Notice that your upper bound is the parabola this time. So I got the opposite of x squared plus 2x minus the lower bound. So I've got minus 3x cubed plus x squared plus 10x. Now, before you go find all the antiderivatives and everything, guys, let's simplify first. I'm going to have -2 to 0. Let's go through and combine some like terms. It looks like I've got a 3x cubed. Looks like my x squareds are out of there. And -10 and -2 make -12x. Plus the antiderivative from 0 to 2 of -3x cubed. X squareds are out of there again. Plus 12x. Now we're ready to find our antiderivatives, evaluate them, and go get the numbers. So I'm running out of room, but it's going to look like this. I'm going to have 3/4 x to the 4th minus 6x squared, evaluated from -2 to 0, plus the antiderivative of -3/4 x to the 4th plus 6x squared, evaluated from 0 to 2. And then it's a bunch of calculator work. Run 0 through this one, get the answer of 0. Run -2 through this part and get an answer of -12. So I'm going to have 0 minus -12 plus run 2 through this one and get 12. Run 0 through there and get 0. So guys, the ending area, by coincidence, this was 12. This was also 12. So this ending area happens to be 24. So there's that one. So guys, the reason we had that extra work to do, it got split up into two different areas. And I apologize if my PowerPoint is choppy. It's freezing up on me, so I'm trying to hit pause and then get it corrected. So, guys, here comes one last one. Once again, I graph the hyperbola 8 over x, and then I graph the parabola y equals x squared. Now, we're also going to have some vertical lines in there. We're going to have the vertical line x equals 1 and the vertical line x equals 4. So let's come in and also draw in our vertical lines. I've already got the parabola and the hyperbola, and we're also going to draw in x equals 1, which is going to give me an area right in here, and x equals 4. So I'm also going to have another area right in there. So notice again, guys, two different areas that we're going to be working with. Well, let's kind of see what we got then. On the first one, my upper bound looks like it's the hyperbola. So I'm going to have 8 over x minus the lower bound, which is the parabola, and we're going to work with that from 1 to 2. Because this point of intersection right here happens to be the point 2, 2. And then let's add to that, once I get some more ink, let's add to that the boundary from 2 to 4. Well, if you look over here, the parabola becomes the upper bound, the hyperbola becomes the lower bound. And then technically, guys, there's little dx's behind here. It's not going to affect our ending answer. But now here goes. The antiderivative of 8 over x. Hopefully you recognize that. That's going to be a natural log. So I'm going to have 8 natural log of x minus 1/3 x cubed. And we'll evaluate that from 1 to 2 plus 1/3 x cubed minus 8 natural log of x, and we will evaluate that from 2 to 4. Hopefully